6.2 page today. Now let's look in our note sheets, or not our note sheets, this packet here. It says 6.2 notes. Today we're going to talk about the vector dot product. And again, there is a huge amount of information in here, and that's why we're going to take Monday as kind of a catch-up day. Then we'll quiz on Tuesday. We've got a couple of vectors. Now let's make sure you're clear on this. These two vectors, are we running?
Yeah.
Okay. These two vectors, if you wanted to draw them, you could draw them anywhere you wanted. I like to start mine at the origin. So that first vector goes over 1 and down 3. So that first vector would look like this. Does that make sense to everybody? Now you can put him anywhere you want because vectors don't have position. Vectors have direction and magnitude. So the magnitude of this vector is root 10. How did I get that? How did I get root 10 for the magnitude of this vector? The Pythagorean theorem, right? Yep. I went over 1 and down 3. That makes root 10. And the direction of the vector is over 1 down 3. So certainly if I needed it, I could find that angle, right? Now I don't need it right now, but I could find it. I can put that vector anywhere. It's just easier for me to set it at the origin. It's easier for me to graph it and everything else. So that's what that one looks like. You could graph that one. These are the two, these are the two vectors we're using in this problem. Okay? Now, what are we going to do with them? Well, we are going to do what's called the vector dot product. Now, this is something that's a little bit different about vector land. Actually, there's a lot of things different about vector land. One is the vocabulary, right? Let's run through some vocabulary real quick. Magnitude means length, right? Resultant means sum. Scalar means a real number. Usually it's a coefficient, but it's just a real number. What is a vector itself? A directed line segment, right? Okay, well, in vector land, the symbols dot and cross mean different things. Now, in regular arithmetic, if I want to multiply, I can put a dot or I can put that symbol. They both mean multiply, right? But not in vector land. This is called the dot product. And this is called the cross product, and they are different. The biggest difference is the dot product gives you a number, a scalar. So when I find the dot product of these two vectors, I'm going to get a number like 6. Just get a number. The cross product gives you another vector. Today we're talking about the dot product. Please don't ever say V times U. That is confusing. No one knows what you mean. You have to say V dot U or V cross U. Today we're doing the dot. Okay, so we're going to find the dot product of these two vectors. It's really, really easy to find the dot product of these two vectors. So we're going to dot 4U and 1 negative 3. To find the dot product, we take x times x, so 4 times 1, and y times y, and add them together. So it's really simple. If you have the coordinates, it's so easy. Katie and Annabelle, we are discussing the vector dot product. Yeah, right. 4 times 1, 2 times negative 3, add them together, so the dot product is negative 2. Could not be any easier. Now look at number 2. I'm looking at my notes here. Number 2 says do exactly the same thing, but in the other order. What do you think's going to happen if you do 1, -3 dotted with 4, 2? What do you think's going to happen? Isn't the answer going to be exactly the same? Because we're still multiplying x times x and y times y and adding them together, and the order of the multiplication doesn't matter. So the dot product is commutative. Hint for future reference, the cross product is not commutative, but the dot product is. Now, what if, now I'm deviating a little bit from my notes because I want to lead into the next question. What if you had this situation? What if we wanted to find the dot product of these 2 vectors? Well, now we got a problem, don't we? Right? What's our problem? We don't know the x's and y's, right?
Yeah.
Now, yesterday, did we talk about maybe how to find the x's and the y's? Remember the airplanes and all that? Well, that's a lot of work, but you can do that. Turns out there's a shortcut. To get the dot product when you have this kind of situation, if you have the coordinates, you want to do x times x and y times y. But in the real world, kids, you don't always have the coordinates. So if you want to find the dot product of these 2, you take the magnitude of u, or v, the order doesn't matter, the magnitude of v, the magnitude of u, times the cosine of the angle between them. Now this is going to be really handy in a minute, so get this written down. This is another way to find the dot product. Mrs. Ford, how do we know which way to use? Use the way that fits the given information. If you have the ordered pairs, if you have the x's and y's, if you have the components of the vector, do x times x, y times y, and add them up. If you have magnitudes and angles, which is like a real world problem, if you have this situation and you want the dot product, take the magnitude of the first one, which would be 15, the magnitude of the second one, which would be 12, times the cosine of the angle between them, which in this case is 58. Now remember, the dot product is always a number. You're just going to get a number. Now it's going to be a decimal, not a whole number this time, but that doesn't matter. I got 95.385. There's no unit on that. That's just the dot product of these 2 vectors. Now, let's look on our note sheet at problem number 4. I know we haven't done 3 yet, but we're going to. Number 4 says, okay, I've got these 2 vectors out there, 1, -3, and 4, 2, and clearly they form an angle. My job is to find that angle. Now wait a second. Let's look at that situation and this situation. Are the pictures kind of similar? This is the angle between the 2 vectors, right? So that would be this right here. Would you agree with me? I want to know what that angle is. Do I know these 2 things? I don't know them yet, but I can figure them out, right? What's the magnitude of this vector? This was the vector 1, -3. You said its magnitude was root 10? this was the vector 4, 2, what would its magnitude be? Square root of 20 or 2 root 5? So I know the magnitude of my first vector, the magnitude of my second vector, I'm just going to leave it root 20, and I need the cosine of the angle between them. I'm looking for that angle. That's my unknown. Shoot, it would be great if I knew what this was. Then I'd have an equation I could solve. Do I know what that is?
Yes.
Actually, I do, because I figured it out already. Didn't I do v dot u? And if I didn't, I'll do it again. Here are my two vectors. What's v dot u? 4 minus 6. So this is negative 2. What does the dot product do for me? It does a lot, but one of the things it does well is it finds the angle between two vectors. Because now I'll just divide 2 by root 200, negative 2, by root 200, and that's going to give me the cosine. And then what will I do? Yep, second cosine, that decimal, whatever we got. I got that angle to be 98.13 degrees. Anybody match that? All right, let's do the next one and kind of recap all this, because that's a lot of information. So let's kind of see if we can put the pieces together here. Let's look at number 5. Find the angle formed by A and B. I want to find the angle between A and B. Okay, now first of all, A and B are written kind of oddly, aren't they? What would be another way to write vector A? 2, negative 1, and B is negative 3, 4. Now I want the angle between those vectors. Now I just erased it, but when you hear the angle between vectors, what should pop into your mind? Dot product. Because isn't one definition of the dot product magnitude times cosine? Right? By the way, girls had assembly yesterday. It was lovely. Good job. Good work. Magnitude times cosine. So here we go. Dot product equals the magnitude of the first times the magnitude of the second times the cosine of the angle between them. Fill in what you know. What do I know? This is negative 10. How did we get negative 10? 2 times negative 3, negative 1 times 4, add them up. What else do I know? The magnitude of vector A will be the square root of 5. Now some of you have got this. Some of you are still struggling with that. Draw a picture of 2, negative 1. By the way, if your name was here, you now have a detention. 2, negative 1. If you draw 2, negative 1, or in Harry's case, 2 detentions.
What? Oh, can I just give you $1 right now?
You know what? You had a week or 2 weeks or 3 weeks.
I
to
keep
give me a
forgetting,
dollar.
and you never asked. And oh, can I give you $1 right now, Miss Ford?
2 root.
I'll stay after and we'll talk business.
Root 5. The magnitude of that vector is root 5. Now, what about B? What about B? Square root 25, which is just 5, times the cosine of the angle. Kids, you can solve that. So we'll take negative 10 divided by 5 root 5 equals cosine theta. Now I want to caution you. If you're going to type this in, and it's fine, certainly that does reduce, but you can type that in. There's no problem with that. Make sure that you have your denominator in parentheses. anytime you put something into your calculator as a fraction and the denominator has more than one piece, make sure it's in parentheses. So here we go, second cosine, negative 10 divided by 5 root 5. I got 153 degrees, is that what you got? Anybody have any questions about that? Did I get the wrong answer? Now, that will definitely be a question on a quiz and a test at some point in your life. Find the angle between two vectors. So what's the secret? Dot product equals magnitude times cosine. You just start filling in what you can figure out and you'll get it. Now, number 6. Are the following parallel, perpendicular, or neither? Now, this is an important conversation for us to have because in 3 dimensions, which is where we're eventually going, you will not have any other option other than to use the dot product. Right now, given 2 dimensions, if somebody gave me vector P and vector Q and said, are these parallel, perpendicular, or neither, I could use slope. Because if this vector is going right 1 and down 3, what's his slope? Think about how he's moving. He's going right 1 and down 3. So what's his slope? Negative 3 over 1 or negative 3. This guy is going left 2 and up 6. So his slope would be 6 over negative 2, also negative 3?
Yeah.
If they have the same slope, then they are parallel. Let's look at the next one. What's the slope of vector M? So the slope is 3/2. And N, what's the slope of vector N? Negative 4/6, which is negative 2/3. Tell me about those 2 vectors. They're perpendicular. They're negative reciprocals, so these guys are perpendicular. Now that's the case we need to talk about. Because I want to show you, or I want you to think about, what happens when you do the dot product of these 2 vectors. What's the dot product of these 2 vectors? It's 0, right? It's 0. Now I want you to think about this equation right here. If you put a 0 in for the dot product, would it really matter what these 2 magnitudes were? If you put a 0 in here for the dot product, when you divide, aren't you still going to get 0? What angle has a cosine of 0? 90 degrees. 90 degrees. Isn't the x-coordinate 0 up there? So the angle between these 2 vectors is 90 degrees, which means they are perpendicular. Okay? Write this down. If the dot product is 0, the vectors are orthogonal. That is the vector word for perpendicular. We don't say perpendicular, we say orthogonal. If the dot product is 0, the vectors are orthogonal. Right now, that doesn't, you don't even really need that because like I said, you can do these with slope. but in 3 dimensions, there is no slope. So the only way to tell if vectors in 3 space are orthogonal is to do their dot product. We're not ready for it yet, but to tell if they're parallel, you do the cross product. Okay, so somebody looks at 6C. Are these things parallel, perpendicular, or neither? Do a quick dot product in C. Look, using vectors W and C, do a quick dot product. What do you get? They're perpendicular. Actually, we should say orthogonal. Because we get negative 20 plus 20. You guys, I can't tell if you're keeping up with me or not. On 6C, find the dot product of those 2 vectors. X times X, Y times Y. So don't you get 0? That means they're orthogonal. Perpendicular and orthogonal are the same thing. If the dot product is 0, they are orthogonal. If the slopes are opposite reciprocals, they're orthogonal. All right, let's look at number 7. Find the measures of the angles of the triangle. This is another GTQ. You already have a strategy for doing this problem, but we're going to have a new strategy.
Please go back to the change. We'll stab you at this.
Now, I am not plotting these points in any particular location. I'm just putting them up there.
Where is your God now?
And let's say, just for fun, we're going to find angle A. We have to find all of them, so we're just going to find angle A. Now, tell me how you would do this right now. I mean, before we start talking about any new strategies, what old strategies do you have for finding angle A? Hero's formula would find the area of this triangle. What? We're trying to find an angle.
You can
Yeah,
find
we're
2 sides, how long they are.
So we would find the lengths of the sides and then do the law of cosines. That's one strategy you would have. But I think you might be thinking about something a little different, Stephen. You might be thinking about, isn't this the angle between AB and AC?
Yes.
And we just talked about how to find the angle between 2 vectors. So let's see. The vectors that we have in mind are vector AB and vector AC. Now, groupies, if you're looking for angle A, those are your vectors, AB and AC. If you're looking for angle B, then your vectors would be BC and BA. It matters. Get them in the right order. If you want angle C, it would be CA, CB. The angles that come out, or the vectors that come out from the angle. Okay, but we're doing angle A, so these are our vectors. Okay, what are the coordinates of AB? AB, we're going from 1 to 4, and from -2 to 3. What about AC? -3, 4. These are our 2 vectors. I want to know the angle between those 2 vectors. We just talked about this. How do we find the angle between 2 vectors? What do we start with?
Let's get that
The
magnitude.
dot product. We remember that the dot product I'll write it out, equals the magnitude of the first times the magnitude of the second times the cosine of the angle between them. Dot product equals magnitude times cosine. So what's the dot product of these two vectors? What do I get here?
-2.
Oh.
I'm not sure how you got negative 2.
I was looking at the triangle, not that stuff.
Yeah, it was great job.
11.
The dot product is 11, right? -9 plus 20. Okay, what's the magnitude of our first vector? It's going to be a radical. Magnitude of our first vector?
6? No.
Root 34.
6.
Hopefully our wrestling's better than our math is.
Oh!
It will be. It will be.
6.
Okay, AC. AC. Magnitude. All right, so here we go. 11 divided by, watch that denominator. I got 67.83, did you?
Oh, no.
You okay with that? I want you to hang on to that for a minute. Leave that number on your calculator. Did anybody match me? Okay. Look at the next question. Find the area of the triangle. Kids, you're done. You've got it. The area of the triangle will be 1/2 this side, which you already told me is root 34, times this side, which you told me is 5, times the sine of the angle between them. So the area of that triangle is 1/2 this side times the sine of the angle between them. And you already had done that work. So you just crank that in, and that's the area of the triangle. Now use your second answer button.
No, you said I told you so.
Did you get 13.5? I'm going to talk about that too. All right, well, we got some more to talk about. We had a good start. Have a good weekend and good luck to this party. Woo!
Say those 30s. I'm not sure you were saying those 30s. It's a vicious cycle.
Annabelle, one more time, please. Everything I would say.
Madeline, your iPad.
You should have.
Only had one to finish.
Yeah.
I had 13 last.
No one's giving me, like, I definitely deserve it.
Give me any.
Oh.
Don't wear a shirt.